In today's video, we're going to be looking at homeostasis of blood glucose levels. The process of homeostasis maintains a constant internal environment regardless of changes to the external environment. In this video, we'll be looking at how your body maintains a healthy and relatively stable blood glucose level. This occurs despite changes in what you eat and the amount of glucose in your blood. We'll also be doing a little bit of revision on macromolecules and reintroducing the term polysaccharide. That's when you've got lots of glucose molecules joined together in a chain. The word disaccharides, that's when you've got two monomers joined together, as you can see here. And finally, monosaccharides. That's when you've got these single units. We'll also be talking about enzymes. All of the cells in your body need glucose. This glucose gets converted to ATP during cellular respiration. So this is the formula for cellular respiration. We've got glucose plus oxygen forming carbon dioxide plus water and then ATP. This is the ultimate source of energy for all of your cells. Now, I've left blank spaces here because we need to write a balanced equation. So let's balance this equation. I can see that on the left I've got 6 carbons. So I need to put a 6 in front of carbon dioxide. Now I need to balance hydrogen. I can see that I've got 12 hydrogens in glucose, so I need to add a 6 in front of the hydrogen. And now finally, I need to balance oxygens. So you need to add up all of the oxygens on the right-hand side, and you can see that there are 18 oxygens. So I'm going to add a 6 in front of oxygen on the left. So now I've got 18 oxygens on both sides. So here I've got a small intestine that I've drawn up earlier. Now you can kind of think of the small intestine as a big tube, and there are cells on either side, these small intestinal cells. And next to these cells, we've got a very vast network of blood vessels. So here we have glucose entering the small intestine, and glucose is a monomer, a monosaccharide. And the glucose is going to get absorbed by these small intestinal cells. It's going to go into the small intestinal cells, and then it's going to move into the blood vessels. So you're going to have lots of glucose entering your blood vessels. So what happens when you've got lots of glucose entering your blood vessels? Well, your blood glucose levels rise. So your body needs some way of maintaining and regulating these blood glucose levels so they don't get too high or they don't get too low. And it does this using a gland called your pancreas. This is your pancreas. And as you can see here, I've drawn these little red dots which represent islets of Langerhans, which are clusters of very specialized cells. So the pancreas is the gland, and the islets of Langerhans represent these red dots. Now here is an islet of Langerhans I've drawn up earlier. So if you can imagine, this red dot is a 3D circle, and here I've got one that I've cut in half. And you can see there's 2 different cell types in here. We've got red and we've got green. So one is an alpha cell and one is a beta cell. So your pancreas has these islets of Langerhans, which are made up of 2 different cell types, alpha cells and beta cells. So let's discuss the situation where your blood glucose levels are very high, such as after having a meal. You've eaten something, so your blood glucose levels are high. So these alpha cells and these beta cells are chemoreceptor cells. That means that they can respond to a chemical signal. In this case, the chemical signal is going to be glucose. So they're chemoreceptor cells. They respond to a chemical signal. So the blood is going to travel into your pancreas, and if your blood glucose levels are very high, your beta cells are going to produce a peptide-based hormone called insulin. So it's a peptide-based hormone. That means it needs to bind to receptors on the surface of cells. It can't just enter the cell. It needs to bind to a receptor on the surface. And this insulin is going to be produced when your blood glucose levels are high. That is the stimulus for producing insulin. So now let's discuss what happens when your blood glucose levels rise. So here we have homeostasis of your blood glucose levels. That's maintaining a constant and healthy supply of glucose. So here we have a stimulus, which is blood glucose levels. And it's an increased level of blood glucose. So the beta cells of your pancreas are going to secrete insulin, a peptide-based hormone. Now insulin is going to go into your blood and it's going to bind to cells that have a special receptor, the insulin receptor. And this receptor is found on your muscle cells and on your liver cells. Now this is going to cause your muscle cells to absorb the glucose in your blood, to take up the glucose in your blood. And then it's going to cause your liver cells to take up the glucose and store it as glycogen. So muscle cells and liver cells take up the glucose in your blood. So what's going to happen? Your blood glucose levels will drop to a set point. Therefore, your insulin production also drops down. And that is the process of regulating high blood glucose levels. So now let's discuss what's been happening when you've been fasting. Now fasting is when you haven't eaten anything for a long time. So your islets of Langerhans, remember, have got also alpha cells. And these alpha cells are a chemoreceptor. And they are stimulated by low blood glucose levels. So low blood glucose levels are the stimulus that causes alpha cells to produce the peptide-based hormone glucagon. So glucagon will only bind to cells that have the glucagon receptor on the surface of their cells. So in this case, the stimulus is going to be decreased blood glucose levels, such as if you've been fasting for a long period of time, you haven't eaten anything. So obviously your blood is not going to have a lot of glucose in it because you haven't eaten anything. So therefore your alpha cells in your pancreas, which are chemoreceptor cells, are going to release glucagon, a peptide-based hormone, which will bind to cells that have the glucagon receptor. In this case, the cells that have the glucagon receptor are your liver cells. And this stimulates your liver cells to break down the stored polysaccharide glycogen into glucose. And this glucose will be secreted into your blood. So, what's going to happen to your blood glucose levels? Well, they're going to rise back up to the normal levels. So therefore, glucagon production drops, and you've got this homeostasis occurring of your blood glucose levels. So now, if you want a quick trick for how to remember which cells secrete which hormone, this is something I use. The first thing you need to do is write out the alphabet. A, B, C, D, E, F, G, H, I. And now we're going to start with the alpha cells and the beta cells. So you've got A and you've got B. Which comes first? So A stands for alpha, B stands for beta. What's first in the alphabet, A or B? Well, it's A. A comes first. So now we're going to look at glucagon and insulin. And what letters do they start with? Well, glucagon starts with G and insulin starts with I. Now, which comes first in the alphabet, G or I? Well, G comes first and I comes second. So therefore, the ones match up. So alpha cells secrete glucagon and beta cells secrete insulin. So you look at the A and the B, what comes first? A. And you look at the glucagon and the insulin, which letter comes first, G or I? Well, G comes first. So therefore, alpha cells release glucagon and beta cells secrete insulin.